So we're going to look at something that's almost in every single problem where you do free body diagrams, a normal force, but we're going to now, admit that we actually don't know what normal force is. So we're going to ask ourselves, what is it exactly? And I have a pretty good analogy for how you should always think of normal force. Forget that there's a ground, and let's just imagine a dude holding our box here. And this dude is tired. He's making sure that this box doesn't move up or down. So he's causing the net force on this box to be 0 at all times. His job, no matter what the load is he's going to make sure that this box isn't moving up or down. So if nothing's acting on it, this box has some weight, mg, and it's pushing down. If he weren't there, this box would fall. So now he's there supporting it. In order to make that box not move, he has to create an equal and opposite force upwards. So in this case, N equals mg. So that's his job. He's just sitting there pushing upwards with exactly the weight of the box. And in that case, N equals mg. Now the problem with most people in their understanding of normal forces, they think it always equals mg. Well, let's look at this example now. Now there's some dude, scoundrel, and he's sitting on it now. He's adding more force. So he has his own force on top of mg. Let's call him P. And now think of something external to the system pushing down on this guy. And now he's pushing harder because he now has to account for not only the weight of the box but also this extra force. So now his N that he pushes up with is going to be more than mg. It's going to be actually mg plus p. Because his job, remember, is to keep this box from moving. So if there's extra force down, he's got to supply extra force up. Now let's say, instead of the dude sitting there, he's now got some kind of guardian angel that is helping by pulling upwards on this box. Or maybe it's a fisherman, I don't know. And then the box still has mg, but now there's some tension relieving the weight of this box. So this guy is now going to have to push upwards less on this box. So his N is smaller now, and his N is actually mg minus t. So he's just creating it such that the sum force on this box is 0. So now let's start to think about this in real context. Okay, this guy's gone now. Now it's just the ground. But don't forget what we learned here. If it's just the ground, now instead of think of the guy now as the entire Earth pushing back up on your blocks. So you have your box. And now we gotta reiterate that we care about making the sum of all forces 0. And you might see this notated as this. That's all it means. Sum of all forces equals 0. So if nothing's acting on this box, it has mg down. The ground is going to supply the force necessary to make this true, which is N. Now let's say that you add an extra P force here, then you can literally just subtract that off of the length of your N. So now N, if you write it out like this, everything downwards is negative, everything up is positive. N minus P minus mg. I'm sorry. Oh, yeah, that's correct. Because P is downwards, N has to supply even more, so it's longer now. So N minus P minus mg, I got a little ahead of myself, equals 0. So N equals P plus mg. Now, alternatively, if P is upwards, so let's think of it now as a string connected to this box and it's applying tension upwards, then N is still there, but N is going to change again. So now let's equate everything positive is upwards, everything negative is downwards. N plus T minus mg equals 0. N equals mg minus T. And see, we're getting the same results as we did with this example. So you can literally just think of the ground as some dude. You can think of it as Atlas, or just a huge guy that's always here, carrying everything you put on the ground in physics problems and textbooks around the nation. And your N is changing. It's not always mg, so don't make the mistake of automatically equating n to mg. You have to look at all the forces in the vertical direction or perpendicular to the ground. So let's say now you have a force this way. You're going to look at now the y component of that, py, and now you're going to do the same equation. You're going to do n plus py minus mg equals 0. And in this case, if this is an angle, then py is going to be p sine theta. And you can't think of n as this variable thing. N is kind of what's left over. It's what's balancing out the equation in your problem.